Hello, I'm Mr. McBrien. This is TEJ3M Multimeters. Yesterday we talked about schematics and their importance and ways to maximize the chances that we'll communicate well with others, the circuits that we have in mind. Today I want to talk about the need for measuring various circuit parameters. We've already talked about calculations. I want to talk about the need for measurement, techniques for making successful measurements, and then we're going to spend some time finally doing some hands-on stuff, so doing some work with the multimeter. Okay, so we've already messed around with some calculations with power and with calculating current in a circuit using Ohm's law. So you might ask yourself, well, why do we even need to do measurements? Well, calculations are great. They work wonderfully when a circuit is working the way we expect it to. But as soon as a circuit isn't working how we expect, we need to answer some questions. So some of the questions we can answer with a multimeter: is this connection soldered properly? Is this battery dead? Is this power supply working? And how many ohms is this resistor? We can also, with certain multimeters, answer a question about diodes. So some of them have diode testers, and since an LED is a diode, we can check to see if an LED is burnt out by using a specific kind of diode tester. Okay, all of these kinds of things can be answered using a multimeter, and because of its versatility, we tend to use it a great deal. We could design ways to test a lot of these things by building special circuits, but we don't need to because we've always got the multimeter handy. Okay, so the tools within the multimeter. There's a lot. There are a lot of different modes in the multimeter. We won't use all of them. The most important ones for us: the ohm meter, the ammeter, the voltmeter, and the diode tester. And each one of these modes tests a different aspect of the circuit. It answers different questions. So let's start with the ammeter. And no great shock, most multimeters will have an A to show you the ammeter mode. And also no great shock, it measures amps. So what we can do is we can, using the ammeter, we can measure current through any point in the circuit. But there's a catch. The ammeter actually measures the current as it moves through the circuit and through the meter itself. So we've got to force the electrons to flow through the meter. We can think of the meter as calculating the electrons, number of electrons passing through it. And so in order to force those electrons through, and we'll talk a bit more about that on Monday, in order to force those electrons through, we have to break the circuit to make the measurement. And you'll try that out in half an hour or so. So if we wanted to use a circuit diagram, let's say we wanted to measure the current that was running through resistor 1 in this parallel circuit. What we would do is break the connection to resistor 1 and run the electricity through the ammeter. And then we could measure the current that was going through. Okay, and another way of looking at it is this. So we make the multimeter part of the circuit. We put the multimeter in series with the load. And the current runs through the multimeter and we get a measurement as it goes through. Okay. Maybe some of you, that makes you a little nervous, the idea that all this current is running through the multimeter. In fact, it is worth talking about for a second. Since the current flows through the device, there's an issue with if there's too much current through the device, it can actually damage it. So a multimeter on its lowest current setting has a fuse to protect it. So if you set up to measure milliamps and you actually run amps through your multimeter, you can blow a fuse. But If you get really crazy and you set up to measure amps and you measure thousands of amps instead run through it, you'll burn out your device. So you have to use a little bit of caution. Check out the ranges, do some calculation using Ohm's law to estimate the current that you'll see. And always, if you're going to measure current, start with the highest value. And if it registers a really low value, then you can switch to the lowest value and measure it more accurately. I colloquially said, dial it down. Now the other thing is that because of the way that part functions, you actually have to change the position of the leads on the multimeter. There's clear description of how to do that, or clear label of where that goes, and I'll demonstrate that in class as well. So just keep in mind, usually you don't need to measure current in this class. If you need to, you might want to call me over and talk about it. I'll give you some tips on how to do it today. Okay, the ohm meter. No great shock, measures ohms, so it measures the resistance of a given component. And it can help you to confirm that you've made good connections, right? That you can confirm that your soldering joint is good and things like this. And the way you check the resistance is you disconnect power from your circuit, and then you attach your leads across the thing you're measuring the resistance of. So a question for you before you proceed. What do you think the resistance across a soldering joint should be? Think about that for a second. You can pause it if you want to think about it, and I'll answer it now. The answer should be a good soldering joint has a resistance of something very, very close to zero, just like a wire. Okay, and the measurement, you can measure, for example, the resistance of this resistor by just making sure the leads are on either side of the resistor. And most multimeters have ranges, and so if you see 0, you can go ahead and change that to a smaller value for resistance. Okay, the voltmeter. No great shock, measures volts. So it measures the potential difference between any 2 points. So with this, we can confirm that we've got good connections throughout our circuit. We can confirm that we have a live battery or a good power source. Now, the difference here, potential difference, has to be measured with the power supply connected to the circuit. If there's no power supply connected to the circuit, there's no potential difference across anywhere in that circuit. Okay, the diode tester. New multimeters have a diode tester function. The new ones do. And with those, you can test the value and polarity of a diode. And we won't do much of that in this class. I'm not going to emphasize this part. What I can say is that the high-end multimeter that I use, the orange one in the classroom, will actually allow you to test LEDs as well, because LEDs are a kind of diode. Anyway, if you want to test diodes, you simply apply the leads to the appropriate sides and change the diode tester function. If you want to test your LEDs, unfortunately, you need to use a very good multimeter like mine. Okay, so to sum up, multimeters are really useful devices. They're actually critical if you're going to build circuits. Ammeters measure current, voltmeters measure potential, ohm meters measure resistance. Each measurement has a special characteristic associated with it. You need to remember when you use it how to configure your multimeter. And you will be tested on this idea, so I'm going to ask you how you would set up your multimeter if you want to do the various measurements. Okay, for your homework, what I'd like you to do is complete the multimeter worksheet that's been provided to you. There should be some useful exercises there that should help you to better understand how to use the multimeter in the future and maybe even understand circuits a little better. All right, thanks very much. Note that I have posted a movie as well on how to use a multimeter up onto Google Classroom. Have a great day.